In this video, we're going to look at how to use the first order derivative to do some curve sketching. So the first thing we're going to note is that if we have an equation y equal to f of x, then the derivative y prime actually represents the gradient of the graph of f of x. So this represents the gradient or the slope of the graph of f of x. Now, what does this mean? Well, this means that if the derivative is positive, so that means if the derivative is greater than 0, then the gradient of the graph of y is going to be positive. So this implies that the gradient is positive. If the gradient is positive, then the graph of y is going to be a bit like a forward slash. We say it's an increasing function. Okay, so we say y is an increasing function because so we take left to right as the positive direction by default. So if the graph is like a forward slash, then as you traverse along this line, your height actually increases. So that is why we call this an increasing function. And then if on the other hand the derivative is negative, then what it means is that the gradient is also negative, and the function this time is like a backslash. So, and this we call a decreasing function. So function is like this, is called decreasing because as you traverse along this line or this curve, you are actually, your height decreases. So this is called a decreasing function. Let's just look at a graph here, and then we'll put these ideas in context. Suppose we have a graph like this. Let this be point A, point B here, point C, point D, and point E. So just looking at this graph, from what we've said here, it means even if we don't know the equation of this graph, we can tell where the derivative of the function that produces this graph is going to be positive, and when or where the derivative is going to be negative. So from this, for instance, the segments where the graph is upsloping, those ones are increasing, and so in those segments y prime is going to be positive. So if we look at the segment A to B, you can see that this is upsloping, so this is increasing. So we say the graph is increasing there. Then B to C, is decreasing. So the graph is decreasing there. C to D is also decreasing. So decreasing. And then D to E is increasing again. So increasing there. So from what we said earlier, where the graph is increasing, the derivative is positive. Where the graph is decreasing, the derivative is negative. So D to E, the derivative is going to be positive again. Now, A to B is increasing, B to C is decreasing. But notice that there's going to be a point B here where the graph is neither decreasing nor increasing. So let's say something about those points. So the points where the graph is neither increasing nor decreasing, so neither increasing nor decreasing. So these points are called stationary points. These are called stationary points. So this is the stationary in the sense of no movement. So there is neither increase nor decrease. So these points are called stationary points. Notice that there is a more general term which is critical points. So depending on which textbook you're using, you may find these points being called stationary points or critical points. But critical points is a term that refers to a class of points that is slightly bigger than just stationary points. So if you like, stationary points are a subset of critical points. Now, at these points, notice that the derivative is going to be 0. So the derivative is positive this side, negative this side. So at some point, so as you go this way, derivative goes from negative, decreases, and then becomes, so from positive decreases, then becomes negative here. So here it must go through 0. So at B, the derivative is going to be equal to 0. Let's abbreviate this stationary point. So at a stationary point, we are going to always have the derivative being equal to 0. Something else that we're going to have at a stationary point is the tangent is going to be horizontal. So, and a horizontal tangent. All right, so if we go back and look at this graph, then B, for instance, is a stationary point here, and the tangent at B is going to be horizontal. So at B, y prime is equal to 0. Same thing with C. Tangent at C is going to be horizontal. Y prime is 0. D is the last one. Y prime is 0. So B, C, and D are stationary points because the gradient is horizontal, and so the first derivative is 0. Now, stationary points can further be subdivided into what we call turning points or inflection points. So we're just going to do a diagram here. So we have got stationary points at the top. So we have just said if a point is a stationary point, so y prime is 0 for all these ones. Now stationary points can be classified into either what we call turning points, or the other possibility is a stationary point can be what we call an inflection point. So a stationary point is a turning point. Turning point is almost self-explanatory. A stationary point is a turning point if the graph turns at that point. So it may either turn from increasing to decreasing or from decreasing to increasing. Then that point is called a turning point. So looking back at our graph here, B for instance, across B the graph is increasing this side and then it turns and then it's decreasing this side. So B is going to be turning point. At C the graph is decreasing this side and then on the right hand side it's still decreasing, so C is not going to be a turning point, it's going to be an inflection point. D, the graph is decreasing this side and then it's increasing this side, so D is a turning point. So let's say B is a turning point, D is a turning point, C is an inflection point. Now mathematically, so a graph, a point is a turning point, a stationary point is a turning point if the derivative changes sign across that stationary point. It's an inflection point if y prime does not change sign across that point. So again, if you look at B, the left hand side y prime is positive, on the right hand side, immediate right hand side, y prime is negative, so the derivative changes sign. D, on the left hand side y prime is negative, on the right hand side y prime is positive. All right, and then turning points can further be classified as relative or local. So relative maximum, or we also call this local maximum, or relative minimum or local minimum. So either relative maximum or relative minimum. So the turning point is called a relative maximum if the derivative changes from positive to negative. So if the derivative changes from positive to negative, then the turning point is called a relative or local maximum. If the derivative changes from negative to positive, then the point is a relative minimum. So take the point B for instance. The derivative on the left hand side is positive, then on the right hand side is negative. It changes from positive to negative, so B is a relative maximum. Okay, so B is a relative maximum. And then D, you're going to find is a relative minimum, because so what happens at D, if this is D, on the left hand side the derivative is negative, which means downsloping. Then on the right hand side the derivative is positive. Whereas for B, the situation is a bit like this. Okay, so if the graph looks a bit like this, then you've got a local maximum. If the graph looks a bit like this, then it's a local minimum. This is just a crude sketch using straight lines. All right, so that is the idea. Those are the ideas that we can use to sketch graphs using the first order derivative. So notice that here critical points refers to points where y prime is 0, but also to points where y prime does not exist. Okay, so if y prime is not defined, then so the combination or the union of these two types of points is called critical points. And then just these ones, they are called stationary points. Lastly, a grammatical pointer. So in terms of maximum and minimum, you've got one maximum, and then you've got two maxima. It's the same thing with minimum. One minimum, two minima. All right, so we're going to end it here. In the next video, we're going to look at how to use the second order derivative to help us sketch graphs. Thank you for watching. Hopefully it's been useful. Do not forget to subscribe so that we can make more videos like this.